welcome to DevOpsCon. I'm here with Quentin. Hey, how was your session?
Great, I hope, for the people inside the room.
What did you talk about?
I talked about all the problem we face implementing microservice architecture, because a lot of talk about microservice architecture. It's awesome. But the point is, there were several things complicated when you implement microservice. So I decided to write a talk about complicated stuff on microservice architecture and try to figure out what would be a good solution. We find out at every class. That's a good solution.
Let's focus on that. I mean, obviously, microservices represent one of the biggest buzzwords right now. Everyone is talking about microservices, but this doesn't mean it is actually a silver bullet, right? So what are the problems, concrete problems that arise when going down the microservices path?
I think the first problem is communication, because a lot of people are doing the communication between microservices, like they're doing the application microservice before. And I think microservice is a very good opportunity for people to introduce event bus, because it's loosely coupling, it's able to duplicate data, it's able to somehow track you to the way to using event sourcing management of the data inside the system. So I think the first point is to start on the event bus, because it's way more simpler than manage all the routing of HTTP and all the hard coupling of HTTP and everything. I think the second problem is the distribution of configuration, because at the beginning you have just one application, you configure it right in, that's it. But when you start to have to orchestrate all configuration of several service with interdependencies between them, you're starting to have to think how to manage it. And I put it for something simple like iterate the environment variable, and you can iterate the environment variable for everywhere. You can use it at STD console or not of this kind of technology. Internally at Clever Cloud, you're using traditional database on some point some Zookeeper or something like that, but it's still very simple. And I think the other very big difficulty point is the authentication and how to distribute authentication, because it's not the same application. No, actually get the user password and distribute the authentication to another service. If someone going there, how can be sure that he have the access to the service, and who is it? Because maybe I need some identity about this user. And for this, I explain what the approach on shared repository or with proxy or this kind of stuff are not ideal, but I explain why tokens are really interesting on the security point of view and for architecture system with no single point of failure. And to finish, I explain that microservice is also important to work on a deployment agility system, because you will have to deploy way more applications than before with complex orchestration. So you will need to have the ability to deploy simply and without downtime, something like that. And there is the point where I mentioned that Clever Cloud is building deployment automation system and application sustainability system in it.
And you also said that HTTP is probably not the ideal way to do microservices. Why is that? And what is the other solution, let's say?
I think the point is HTTP is awesome. I don't want to be confusing about that, but if you're taking an HTTP approach, HTTP calling a server, and if the server is there, it's great, and it will send the message. If the server is not great, it will not send the message. So basically, it means that you need to have a very complex order of which microservice has to start before another, which is kind of boring, because on a failure recovery, you will maybe find around that you have a cycle dependency or something like that. The other point is, when you have an HTTP service, it's not a message left on the box. I prefer to have all the data left on message box that people can grab and say, oh, there is an event there. I will open and discover all with it. With HTTP, you need to actually describe all the service you need to ping of an event. And it's not ideal because each time you want to add a service, you will need to edit all the service on your platform, which is not, I like to call the playground architecture application. I prefer to have a playground and say, oh, I want to build a new service. Oh, cool. I will take the data from this message box, duplicate it there, and I plug myself that, and plug that, and that. Oh, sure, we have a new feature. Do we want to plug it to production, or just it's for fun? And with this, it's kind of cool because we don't need to actually pollute all the system with that. So I prefer event system with an event bus like RabbitMQ or all IMQP based system, or a Kafka if people prefer it, or if they want to use ZeroMQ, Redis, I don't know what. But build around an event bus will be a better idea, and with preference for RabbitMQ and Kafka.
And how about tokens? Because you mentioned them, and how do they are kind of like, let's say, a rather new addition to the whole microservices ecosystem. How do they work? Why did you talk about tokens in your session?
Because first we need to enforce the security of the web in general.
Yeah.
And if you're looking at it, the first point to be able to destroy an infrastructure is to be able to destroy a single point of failure. For example, old architecture are basically VPN to an infrastructure endpoint. And if you kill the VPN, and you are already inside, you're basically closing the defenders out of the castle. And exactly the same for authentication. Authentication, if the authentication of a single point of failure, if you can break it, it will be way more complicated to actually detect all the attacks have been propagating. And now we have a lot of computing power, so we can use a lot of cryptography. So there is a lot of interesting stuff going around this particular computer science around, and one is the ability of signed token. So basically you have your, for example, explaining macarons. If someone authenticates against me, I give them back a macaron. And the macaron contains itself the proof that I said this guy is Hawk and it's this guy. So with a lot of data inside it. And things that I help a lot because the macarons itself is the proof that I say it's Hawk. If I go to bed and sleep, the macaron is still there. So if another service needs to authenticate this guy, it will not ping me. So if I'm not viable, it's okay. The other point about the macarons is you can actually precisely describe inside it what you allow this guy to do. For example, read and write tweets, which is an ability. And when the user of the macaron, using the macaron, it craft another macaron which have equal permission or less permission than the first one. So it can give to his secretary, for example, a macaron with only read tweets, which is really useful to delegate authentication. And the authentication delegation is quite complicated, but very useful today. If you're looking at it, we all using a lot of authentication delegation, but for doing this, we're using OAuth, which is precise implementation of everything. So it's quite complicated to do this kind of thing. So I think it can be very useful to have more of these tools aware, because it's more based on signature, it's more based on cryptography, and it's have more features than what we do today.
So we should basically keep an eye on
you should basically keep an eye on macarons, especially because just a few people know it. And there is a very good paper called Macaron Are Better Than Cookies, which can be agree or disagree because I like cookies. But the point is, the paper is very cool and very understandable. So.
And well, we talked about the problems and all, so let's move a bit on the brighter side, there are obviously cases in which it's better to transform a monolith into a myriad of independent microservices, right? And when and why is it better to transform a monolith into microservices?
I think there's few stuff we need to look around. The first is maybe your monolith and a lot of regional part of your code. You know, this kind of code will actually have not a lot of connection with other parts of the code. So this part are not really used to be together. So it can be interesting to just cut it now because it will be simple the maintenance later. Other reasons can be you have one API endpoint which takes 95% of the traffic. It's easily used, and all the other endpoints are largely less used. The point is, you will need to scale this endpoint, but not necessarily the others. Scale the entire application can be very complicated because maybe you have transactional data, maybe you need to have low latency answer to something, maybe you need to connect to complex database, I don't know. But maybe this endpoint alone will be way more simple to scale just alone. And it's kind of the good point of the microservices. You will be able to have different scaling agenda there. The other point is about tools. When I'm doing some work, I'm not using a hammer all the time because hammer is just nice for some tools. And now we have a lot of tech stack, and I know all the developers love to talk about, yeah, Node.js is better, Java is better, Scala is better, Rust is better. No, Rust is better, but I don't know. But the point is, you have all these kind of tools, and it can be very useful to just like use it, play with it, and do some good stuff about that. If you're looking at it, sometimes you want to choose a language because you like it, but sometimes it's because of the ecosystem. And there is some language with very cool libraries, for example, doing machine learning and stuff like that.
Yeah.
And you want to use these libraries inside your application. And doing that, you will need to change your language. So microservices is the ability to use all the tools you need when you need. So it's kind of the good ideas you can have to just split your monolith. It's more because it can be useful. Just don't split your monolith by dogma saying microservices are better. Split it because sometimes it can be useful for you.
In order not to create a monster, for example?
Sorry?
In order to not create a monster? Or?
In order to not creating a monster, exactly. You know, this kind of stuff like, yeah, we haven't a library of WebSocket there, so we make polling. Yeah, but it's not a good idea like right now because you have a chat with 10,000 people right now, and it's a lot of requests, and your database is melting. Yeah, just scale the database. Yeah, but, you know, MySQL is not scalable forever. So sometimes you need this kind of find the good tools and not create monsters.
And speaking of teamwork and decisions and everything, there's definitely not a correct way to do microservices for sure. But what should teams take into consideration before using microservices as a whole? I mean,
we basically use the microservice from the beginning. Without it would be called like that because we think about distribution all the time. And at this time, I was a big fan of SOA, which is services-oriented architecture, which is a really bad word today because for everyone it's kind of consultants selling expensive product to customers. But the basic idea of thing, one service can actually to give a contract of service to all this application is a very good idea. And I think with microservice, we're just doing what SOA was promising, but in a better implementation. And the promises was, we have a service, it promises contract to other services, let's go. And in the beginning, we're working like that. And when someone wants a microservice now, it's more like, it's speaking with the CTO majority, and the CTO is thinking about that and saying yes, not. Today we have the architecture on this part is more CTO driven than other stuff.
And last but not least, what are the, let's say, the rules of microservices deployment? Better yet, what are the characteristics that should be applied to all microservices, if there are any, obviously?
I don't know if it's only on microservice or application for today, but I think that I'm not saying that an application have to, but I think that the 12-factor application have been made several years ago and are still very usable. Very simple, like it have to be simple to start the application because there is one endpoint. If you're looking at even big Java application with application servers, are now launchable with just the Java-jar, which, for example, we have with JBoss Swarm, who's able to package an entire application server in a very simple way. You also have that, so an application will be auto-executable, will be great. The other point is to have the ability to collect the log on a single output. I think an application having to manage his log lifecycle inside himself. Just put it on the standard output will be better. The other point is, less you write on the file system, better you are. Because file systems are very complex to scale, are very complex to maintain. So if you're able to do all the stuff inside database or object storage, I think it will be better. But sometimes you still need to write on a file system. But I think it will be better. I think the configuration will be iterated only by environment variable will be the better way. Because you don't know all environment variable can be iterated, but this can be the best solution to provide to all applications. So if you're looking at all these rules, it's more or less 12-factor stuff. And it's more like creating small application you can launch itself and configure easily with a few management inside it. And I think it's more this way we build modern applications today.
Mm-hmm. Well, thank you for the info. That's it, and have a nice conference.
Thank you very much. Thank you for bringing me here.